You know, every time you click that Pay Now button, you're kicking off this incredibly complex symphony of technology. It feels simple, right? But behind the scenes, systems are juggling millions of requests, and a single millisecond can be the difference between a happy customer and a lost sale. So today, we're going to dive deep into how one company, Razorpay, completely re-engineered its entire system to handle this insane scale, and what we can all learn from their journey.
I mean, this is the question, right? It's the exact challenge Razorpay ran into head first. It's a classic problem when you're growing like crazy. The very architecture that got you off the ground suddenly becomes the anchor holding you back. So how do you rebuild the plane while it's in mid-flight, carrying millions of paying customers?
Well, like a lot of startups, Razorpay started with what's called a monolith. Just imagine one single massive factory where everything happens under one roof, from making the product to printing the invoices to handling customer support. It's simple at first, sure, but it has one critical weakness. And that weakness, it's got a name: the noisy neighbor problem. This is the crisis that threatened to bring their entire system to a screeching halt. It's basically a fight for resources that starts small, but trust me, can cause catastrophic failures. So the conflict boils down to this. On one side, you've got your instant payments. This is the core business, the moneymaker, and they need to be lightning fast. But on the other side, you have these heavy, slow jobs, like generating a giant monthly report. In a monolith, they're both yelling for the same server's attention. It's kind of like your roommate throwing a loud party while you're trying to take a super important business call in the exact same room. It's not going to end well. And the consequences were really, really severe. A single resource-hungry report could just eat up all the CPU, causing a payment request to time out. A slow database query could lock up a critical table, and then boom, a domino effect of cascading failures across the whole system. The most important thing to get here is that a non-critical task could literally kill a payment, costing real money. Okay, so faced with this existential risk, Razorpay didn't just put a Band-Aid on it. No, they decided to strategically tear it down and rebuild it from the ground up. This was called the Decomp Initiative, a complete rethinking of their entire architecture. And they had a super clear three-part plan. First, fault isolation. A problem with sending email receipts should never bring down payments, period. Second, independent scalability. Let the payment services scale up when needed without having to scale everything else. And third, technological freedom. Get out of the old legacy code and use the best tool for each specific job. This was their blueprint for dismantling the beast. The hero of this first chapter is a custom-built API gateway they named Edge. The best way to think about it is as a brilliant, multilingual bouncer at the front door of a massive nightclub. It doesn't just check your ID. It knows who you are, where you're supposed to go, and exactly how important you are. So, how does it work? Well, Edge is not a dumb router. It actually performs what they call context extraction on every single request that comes in. It knows which merchant is calling, what they're trying to do, and even whether it's a test or a live transaction. It understands the business context, which, believe me, is a total game changer for routing traffic intelligently. This is where it gets really clever. Once Edge authenticates a request, it issues something called a passport. Think of it as a secure digital ID that travels with the request. It basically tells every other service downstream, hey, this user is legit, and here's everything they're allowed to do. This means those services no longer have to constantly call back to a central database to check permissions, which, as you can imagine, speeds things up dramatically. And the result of this new front door and passport system? Get this, a nearly 50% reduction in internal latencies. By handling all that authentication work right at the edge, they just chopped out a massive bottleneck and made the entire system way, way faster. All right, so the front door is secure and efficient. Now it was time to fix the core engine room. This is where we get into the really clever engineering hacks that let them scale to handle truly high-speed money. So here's the next big challenge for you. Imagine a company trying to send cash back to 10,000 customers at the exact same moment. In a traditional database, all 10,000 of those requests would try to update the same single row for the account balance. It's a recipe for a massive digital traffic jam, a classic bottleneck. Their solution was so simple, it's brilliant. Instead of one account balance row, they split it into multiple sub-balances. So now, incoming requests can be processed in parallel, with each one hitting a different sub-balance row. It's like a bank going from having one teller window to suddenly opening 10, serving 10 customers all at once. Problem solved. Another huge problem is that your partner banks can go down without any warning. Razorpay's old method for detecting this took minutes, and for those few minutes, every single payment would fail. By switching to a real-time data analysis tool called Apache Flink, they could watch the flow of transactions constantly, cutting that detection time down from minutes to mere seconds.
So how does it do it? Basically, it's always watching the live stream of payments. If it sees a sudden spike in failures coming from one specific bank, it automatically makes a decision. Stop sending traffic there. The system can now effectively heal itself, rerouting payments away from a failing partner before most customers even have a clue there's a problem.
So you see, all of this complex work, it wasn't just about speed. It was about building a resilient and, just as importantly, an efficient future. The payoffs from these decisions were enormous, not just in performance, but in cost, too.
A great example of this is their migration to a new type of processor, AWS Graviton. This shows a really mature engineering culture where performance per dollar becomes a key metric. It's not just about, does it work? It's about, does it work efficiently? And I mean, the results speak for themselves. Their API gateway required 16% less CPU power to do the exact same amount of work on these new processors. That's literally getting more done with less. But this is the real jaw-dropper. That same migration resulted in a massive 70% reduction in peak latency for their API gateway. 70%! That is a colossal improvement that translates directly into a better, faster experience for every single user. This quote really just sums it all up, doesn't it? What Razorpay pulled off isn't just a one-off fix. It's practically a model for how to build financial systems that can actually withstand the insane pressures of hypergrowth. So what are the big lessons here for anyone out there building at scale? First, build your intelligence at the edge. A smart gateway isn't just a door, it's a platform that simplifies your whole system. Second, use real-time data to build self-healing systems. Move from being reactive to being proactive, and you can stop catastrophes before they even start. Third, solve your database bottlenecks at the application level. Don't just throw more hardware at the problem. Clever design, like that subbalance trick, can give you massive wins. And finally, make cost a core engineering goal. Real efficiency isn't just about speed, it's about performance per dollar. This whole journey just leaves us with a fascinating final thought. When the pipes that carry our money become this intelligent, this fast, and this resilient, what new kinds of financial services even become possible? What does the future of money look like when the infrastructure itself is an active, intelligent partner in every single